Stoichiometry notes. All right, stoichiometry, and I know you're going to love saying that word, refers to the calculations of chemical quantities from balanced chemical equations. So they need to be balanced before we can solve. The ones I'm giving you right now are balanced, but in the next unit you will have to balance them yourselves. So balancing is from first semester, remember. Okay, stoichiometry is Greek for measuring elements. Okay, so stoichiometry is kind of like baking cookies. It's a recipe for the exact amount of each element I need. Okay, so that way if I can double or I can triple the amount I'm going to need for my reaction. So a recipe is just like a balanced equation. Okay, let's look at another everyday example. To make a basketball team, we're going to need 2 guards, 2G, plus 2 forwards, and 1 center. Okay, and that's going to give us a team, this chemical equation for a team. Okay? And so say we wanted to make 7 teams. So how many guards would we need? Well, 7 times 2 is 14, right? How many forwards would we need for 8 teams? So we would need 16. All right, so then if I have 8 centers, 17 forwards, and 14 guards, how many teams can I make? Well, I know I can make 7 with that many, right? And I can make 8 with 17 forwards, right? And I can make 8. But what's going to happen? I can only make 7 teams because I don't have enough guards to make 4. So I can make 7 teams, but because I will run out of guards first. This is just like in a reaction. I'm going to run out of one element first, okay, when everything starts combining. This is what stoichiometry is. So first let's look at mole to mole conversions. All right, those are the first ones you're going to do. A mole conversion factor comes from the coefficients of the balanced chemical equation. Okay, what are the coefficients? Let's remind ourselves. When we have a balanced chemical equation, the numbers in the front are the coefficients. Okay, if there's not a number, remember there's an understood 1. So here's our coefficients, 1, 3, 2, from our balanced chemical equation. Now let's look at example number 1. You're going to need your stoichiometry cheat sheet. It tells you the steps for solving these. We're doing moles to moles right now. It's loaded in Canvas if you don't have one, or you can get one from me. All right, so let's look at our example here. It says, how many moles of ammonia? That is the question. Moles of ammonia, this is ammonia, can be made from 7 moles of nitrogen reacting with an excess of hydrogen. So what do I know? That I have 7 moles of nitrogen. So according to this, I'm going to assign X for the given. Okay, so what's given to me? Moles of nitrogen. So I'm going to put an X over nitrogen. What do I want to know? I want to know how many moles of ammonia. This is ammonia, so I'm going to put a Y over that. Assign X and Y. Okay, X is the given, Y is the 1. Determine what kind of calculation you're going to perform. And I told you these are all moles to moles. So here's our little cheat sheet to set it up. Okay, so it's going to be 1 train track. So I'm going to set that up, and what goes here? This is our start box, so we put what we know. I've got 7 moles of ammonia. So we've already done mole problems, so I know to cancel moles of nitrogen, I said ammonia, moles of nitrogen, I need to cancel with moles of nitrogen. And what am I converting to? Moles of ammonia. Okay, here's where I'm going to go back to that cheat sheet, because where am I getting the numbers to do the calculation? It says take the coefficient in front of the Y over the coefficient in front of the X. This is what we call the mole ratio. Okay, so in front of my Y, I've got 2, and in front of my X, I've got 1. The mole ratio of ammonia to nitrogen is 2 to 1. All right, so for every 1 mole of nitrogen, I need 2 moles of ammonia. That's what that's telling you. So to calculate how many moles of ammonia we're going to need, it's multiply across the top, divide by the bottom. So 7 times 2 is 14. 14 divided by 1 is 14. Moles of nitrogen cancel, and I'm left with moles of ammonia. Okay, that's pretty simple, right? What do I know? What do I want to know? Just like doing the other mole problems that we've done. Let's look at this one, number 2. How many moles of hydrogen, that's what I want to know, are required to completely react with 8 moles of nitrogen to produce ammonia? So this time I know what? How many moles of nitrogen again, but I want to know how many moles of hydrogen. So hydrogen gets my Y. Again, set up your train tracks, and these are still moles to moles. I assigned X and Y. I know it's moles to moles, so it's one train track. Let's get that set up. What I know goes in the start box. Moles of nitrogen. How do I cancel moles of nitrogen with moles of nitrogen? What am I converting to? Moles of hydrogen. Where do the numbers come from? It's the mole ratio, coefficient of Y over the coefficient of X. Coefficient of Y is 3 moles of hydrogen for every 1 mole. Remember, there'd be an understood 1 there. So 3 moles of hydrogen to every 1 mole of nitrogen. Moles of nitrogen cancel. Again, multiply across the top, divide by the bottom. What do we get? 24 moles of hydrogen is our answer. Okay, oops, cut that off. All right, so I want you to practice on 3, 4, and 5 and see if you can do this. At least be able to find X and Y. If you need more help, I will be happy to help you.